Hi everybody, welcome back. Today on the bench there is such thing that when I see at very reasonable price I can resist, and indeed I couldn't, and I get off eBay this HP 5328B universal counter. The counter itself is nothing special except that can have very neat options, which this one doesn't have. Can have the voltmeter as well as the C channel that can go up to 1.3 gigahertz. But the main reason is because I like the shape, and another reason is that I wish to find a voltmeter option in the future. There is also the high stability organized oscillator option, which again this doesn't have. But all in all, it's pretty basic in terms of option, but it's worth the try, the attempt to save it. The power button, it's broken and it has been declared by the seller, and it has shown it powered up, so I'm not going to power it up slowly. It's just go straight away. But the seller has declared that it's frozen in the display that we will see, and nothing can happen, no measurements, nothing. So before to go ahead, I want to remove the top lid and see how it's inside. So the screw is removed. I hope it's complete, and again the seller says that it should be. So let's give a quick look. Well, not too bad actually, not too bad. These are the options connectors, and there will be, sorry for the shake, another one over here that is for the organized internal oscillator, and I'm just looking for something obvious, which I don't see. This is the rear, and as you can see, no options. It's ticket, so very basic. Well, let's see how it does. Well, while I was looking around, I've spotted these two Rifa caps, which I'm going to clip and I will replace later on. So let's do that now. So the caps are removed, but I'm looking at this sort of ribbon cable, and doesn't look very nice. Don't know if there is a problem with it. However, let's plug it in and see what it does. Remember, this power switch is broken, and we are in standby, and don't know how they have done. Okay, I managed to start. There is a squealing noise. And reset, doesn't reset. Frequency A. Okay, that has stopped because of this broken power button. So let's try to manage it in some way. Well, I managed to get this running, However, we have no change in function nor in the frequency resolution. No signs of life at all. No, nothing happened. So the first thing that I want to check is the internal oscillator. Okay, this is the internal oscillator with the 10 megahertz crystal and the frequency adjustment capacitor. This is the, despite seems a transistor, this is a 10 megahertz crystal. So need to check if we have the right signal over there, and if we do, we then need to check all the power rails. I have temporarily removed the HPAB board, and I want to check the frequency onto these three ICs, and this is the first step of oscillation generation. Then there is a second gate and a third one, and by the logic of the internal and external switching, we should see some signal. I have not yet printed out the schematic. For the moment, I want to check how it's going on, and here we have some reworking signs. It's the socket of this nasty ribbon cable. Okay, so the first output is on pin 3 of A15, and it is at the right frequency but very low level. So I'm afraid we might have some power supply problem, so better that I go onto the check of the power rails. So let's test the power rails. I've seen some indication onto the PCB, still a squealing noise, so let's check plus 25. We have plus 5, which we also have a bit higher, minus 5.2. We have plus 0.4. This is not correct. Let's check the plus 3.5. Completely zero. Second one, we have it. So we have this is ground actually. So it seems that it's missing the minus 5.2. Let's check it out. Well, looking at the schematic, which unfortunately still I don't have a printed out, and I have in this phone, which I'm using to film this, I have seen that we have a fuse onto the minus 5.2 lines, actually before the unregulated voltage, and it's open. So we might have a problem, maybe capacitor or transistor. Well, before to make any troubleshooting, I have applied this external power supply with current limiting. Maximum current is 1.2 amp. The fuse was 2 amp, so still not installed. Let's try to give 5 volt. And it's creeping up 0.3, 0.6, 0.9. Okay, we have some change here. Oh, look at that. It's doing something now. Okay, now it's yeah, clearly need the minus 5 volt. Let's try to apply the new fuse. New fuse is installed. 3, 2, 1. Okay. Okay, it seems that it's working, at least to some extent. There is still this squealing noise, which I don't like, honestly. I don't know if there is a ripple or what, but I can now check the power aids. Checking the power aids, we also missed the -15 that, and on this rail I'm afraid we have a dead short. We have 2.4 ohm. So let's check what is overloading it. Well, as I want to isolate the power supply side from the motherboard, I have removed the bottom cover to lift this jumper, which I think it's a 0 ohm resistor, and I spotted another Rifa cap ready to explode, so I will clip it off as the other two. So I've lifted the 0 ohm resistor or jumper, and the short circuit is on the motherboard. From the power supply side, we are okay. So let's remove the board one by one and see if we have some change. The removal of the board, it's pretty difficult. They are very tight in the socket. Maybe it's several decades that are in place. I have already removed the connector onto the HPIB. This board I've been able to remove, but no change in the short circuit. So I have removed the side panel. I will lift with a screwdriver, helping to lift from the connectors, avoiding the breakage of the main board as it is possible, and the connector and the small board itself. Well, I've removed the first board, and I have a convenient point of measurement here, and no change, still short. Well, the removal of the second board, it's quite difficult as it's connected to the front panel as well as this one. So I need to remove this section of the front panel in order to make them free. I have removed this portion of the front panel, and I'm going to check, still that short. I have removed the second board. I'm sorry, I'm calling the first and the second, as I still have to familiarize, and I still don't know the exact function of each board. However, I have removed it, so let's check what we have. And we have still that short. And the removal of the last board on this side has not released the short. Remove the last board here, we still have a short. So it's on the motherboard. As I have to repair the power switch, I've removed also this section, but still that short. Well, checking the capacitors onto the motherboard, I lift the very first and immediately has released the short circuit. So we found our culprit, I think. So let's check. Oh, look at that. Very dead short. So let's replace it. I have replaced the capacitor with a tantalum 2.2 35 volt capacitor. So it's time to a quick reassembly and check before a good cleaning. Well, as I have to attempt to repair or replace the main switch, I have removed the front panel PCB from its shell, and the glass is pretty dirty and scratched. Hopefully I can save it. I was trying to remove also this PCB, but somebody in the past has stripped the small screws inside this knob, so I need to make some special tool to try to save the screws themselves and the knob. So let's remove this switch. I've disassembled the main switch, and there is nothing wrong except the lever, which is bent. I will attempt to straighten it. It's quite possible that it will break, so let's hope for a save. It seems that I have saved it, and it's now dumping, so let's try to reassemble it. And that's the main switch repaired. Unbelievable, isn't it? Well, I've reassembled everything. Actually, I have already cleaned the main board. I have spread with contact cleaner all the connectors, including the front panels, the two sections. So I'm going to check without the HPAB board. It should be good, the same. So I will apply power. 3, 2, 1. Okay. The squealing noise has disappeared. That is a good sign. So the short circuit for sure. And we have okay, overflow. We are in check, so I should see a count. Oh, look at that. Seems that is working, at least to this extent. So at this point we need to apply some signal and see if we can count. I'm applying 2 megahertz from that source, 200 millivolt. Look at that, it's counting. 2 megahertz. Okay. So let's see what it does here. Look at that. And let's check to the maximum range. I think it will take 10 seconds. Oh, look at that. That's not bad. Not bad at all. I think we can call it repaired. Let's check on channel B. Well, as you can see, everything is reassembled. I'm applying signal to both channels. Both channels are working. I'm measuring the ratio. This is time interval. I don't know what should be. This is the average time interval, average A to B. I'm applying on channel A 3 megahertz, on channel B 5 megahertz, which is exactly this ratio. So the counter is working as it should. We have a nice power button, power switch working perfectly. We can measure the frequency, which is quite precise. Not yet touched any adjustment, and before to do that I want to use the instrument for a bit, so everything will be back in business for a longer time than a few minutes. The instrument, I believe it has been kept off quite a long time. I have discovered another thing that I'm going to show you now. Well, as you can see, it's missing the fuse holder. and it seems that in the past the fuse seems not necessary, so they've simply jumped the wire together, and in this case we don't have any kind of protection. So I need to find the fuse holder, or at least the lead. I still have to replace the Rifa caps, but I have finished the stock of those, so the instrument can be used the same despite the missing of the fuse holder, which, by the way, I have removed the plug. So the instrument is back operative. Looking at the back of an old rear panel of a wrench, an instrument wrench, I found the appropriate fuse holder cap. So I've installed the 1 amp fuse as required for 250 volt, and I have moved the wire in the proper location, so we should be good to go. And I will install the top cover and test it again. And that is the finished instrument, with all it takes to bring it back to working condition. That is the real cause of everything. This is a blown fuse, probably due a short circuit. These are, I've just replaced it for safety reason. The instrument is working. I'm hearing again a bit squealing noise, so don't know what that means. It is in need of calibration, and as said, I will perform it after a bit of time that I'm using it. I want to be sure that everything is working as expected, but I think it's a nice add to the lab. Hopefully in the future we'll be able to find the voltmeter and C channel options, as well as the ovenized oscillator. But for the moment, it's it's nice to have it back in life. So I thank you very much for watching, and I'll be back soon for more interesting videos. Bye.